Okay, so let's wrap this up with a quick question and then an example. So true, false. We can always translate a program from structured code to GoTo or linear code. What do you think? So the answer to this is yes. And not only can we always do the translation, we can actually do it automatically. So all of this business that we are doing of translating from C code down to assembly code, that's what your compiler does for you. And we're not concerned in this course too much with how that's done. We just want you to be able to do it manually for some small examples, but it is possible to do it automatically. And if you're interested in how this works, again, I would urge you to consider taking CS 432 as your advanced systems elective, where you will learn how a compiler works and actually implement one yourself. Okay, so let's do this exercise here. So convert the following C function into x86 64 assembly. And there are many ways you could go about doing this, but let's see one solution. So here we're going to, let's look at the code first. So we set sum to 0, we set x to 1, while x is less than 10, we add x to the sum, we add 1 to x. So basically this is just going to sum up the numbers from basically 1 through 9, right? So the hint here is use jump to middle for the while loop. But before we get to the while loop, we should go ahead and translate these first two, right? So let's just pick two arbitrary registers. We'll use sum and store it in one register, and we'll store sum in one register, and we'll store x in another register. And so we'll start with two instructions that set those registers to their initial values, 0 and 1. So let's just arbitrarily choose to store sum in the EAX register, and we'll store x in the EDX register. So over here, we'll add some comments showing what the instructions are equivalent to in terms of the C code. So we're just going to initialize EAX to 0, so that's the sum, and then EDX to 1, which is the x. All right, so we've been given the hint to use jump to middle, so we can go ahead and set up that template. So to jump to middle, we're going to have our jump to the middle. So that's this jump instruction to some label, which is where our test needs to go. So we'll actually just name the label test. Down there, we need to do our comparison and our jump back up to the top. So that's what this looks like. And then we can go ahead and fill in our comparison because it's right here. So we're comparing EDX, which is x. So we want to compare x to 10. And if x is less than 10, then we want to keep executing the loop. So that's the setup there. And then the rest of it is relatively straightforward to fill in. We just need to, inside of the loop, we need to add x to sum. So we need to add EDX to EAX, and then we need to increment x. So we could do that with the increment instruction, or we could just add 1 to EDX. So that's the assembly, or that's one assembly equivalent. And like I mentioned earlier, there are any number of correct assembly programs that are equivalent to this. And so typically what we'll do in this course is we'll give you some of the pieces of the assembly, and we've carefully constructed it in such a way that there's one correct answer that will fit with all of the pieces that we've already given you. So for instance, we might give you some of these instructions but not the others, and we've arranged the instructions that we've given you in a clever way that sort of makes it so that there's only one correct answer, and that just makes it easier to grade so that we don't have 100 different versions. But it's important to realize that there are multiple correct answers to these things if you aren't already given a portion of the answer. And again, I would encourage you to get to the point where you're comfortable coding up assembly snippets on Stu and testing them. I really think that'll help you understand what's going on, particularly as we start to tackle some of the more complicated topics.